Welcome to the video on standard deviation. Let me get this up on the board for us here. Standard deviation. Well, picking up where we left off on the variance video, I left everything the same on the board here. And so we left off knowing that we take the sum of our squared deviation scores, which was column 4 here, column 4, and we divide by n minus 1, which gives us an unbiased estimate of what the actual variance in the population might be. But because these are squared deviation scores, our units then that are attached to them actually become squared. And so consequently, it's not very useful as a descriptive measure. I'm just kind of put over here, not useful. In terms of descriptive, now we can use variance for many other things. In fact, when you get to inferential statistics and you talk about ANOVA, it's analysis of variance. That's what ANOVA stands for. So it's going to be useful in statistical applications, but as a descriptive measure, it's not useful. And let me just put here as, a descriptive measure. Okay? Which kind of sets the stage then for its close relative, which is S, which is our standard deviation. And so if we're talking about the population, we'll go down here to the bottom of the screen, highlight in blue. So if we're talking about the population, it's the Greek lowercase sigma. And if we're talking about the statistic that estimates this, it's S. So S estimates sigma. Okay. So essentially, all we have to do then is S equals the square root of S squared. Of course, another way of seeing this might be or the square root of, and then put in what the actual equation is for variance. So these two would be equivalent to each other, okay? These two here, equivalent. Okay, so let's plug and chug our numbers here. So this is 7.33. And then kind of years squared. Take the square root of this, we'll actually get 2.71, and that gets rid of years squared and just brings us to years. So our actual standard deviation here is 2.71 years. Now the standard deviation is going to be used extensively. It's going to get more fully developed, this idea of the standard deviation, when we start talking about the normal curve. But for right now, this is actually how you measure it. Again, pay specific attention to parameters. These are things about the population, that are characteristics that are describing the population. And then because we rarely know them, what we do is we take a sample from the population that we want to generalize to, and then we measure those same things, okay, and then they're the best estimates of what these parameters might actually be. So statistics estimate the parameters. Okay, so I think that's everything about standard deviation that I want to talk about. Thanks for watching the video.